Hi guys, welcome to NMAT. We have a question here, and the question is to find the domain and range of the following values. We have f of x equal to x, we have g of x equal to 2x plus 4, we have h of x to be equal to 2x plus 1 if x is greater than 0, and x squared if x is greater or equal to 0. Then we have f of x to be equal to 1 over root of 2x plus 5. And then we have g of x equal to square root of 4 minus x squared over x minus 1. Alright, so let's start with the first one that we have f of x to be equal to x, and we have to find the domain and the range. Now the domain here is the input, the values that can be imputed into this value to give into this equation to give us a true value, to give us a true answer, and then the range is the answers that we're going to get if we insert such values. Alright, so the values that we can put into this equation is any number. We can put any number into this value here, x. X can be any value, it can be minus 1, it can be minus 2, it can be 1,000, it can be a million, it can be anything. So we then say that the value ranges from your negative infinity to your positive infinity, which is the same as saying all values. Okay. Alright, and then for the range, which is the answers that you can get if you insert all these values, will still be the same thing, because whatever you insert here is what is going to give you out, since f of x is just x. Alright, and then to positive infinity. So that will be the range of values for this equation. Now let's check out the second one. The second one says that g of x is equal to the square root of 2x plus 4. G of x is equal to the square root of 2x plus 4. And now what we need to take note of is that under the root of an even, under an even root is a root whose power is even. For instance, square root is an even root, fourth root is an even root, sixth root is an even root. Now this root, the value that is inside of it should not be negative. And all values that are negative are less than 0. So another way of saying negative value is to say the value is less than 0. So if you write value less than 0, all you're trying to say is that that value is negative. Okay? And then if you say that the value is greater than 0, what you're saying is that the set of values that you're having is positive. Okay? Alright, so we don't need a negative value here. So all we need now are positive values or 0. So the value can be positive or the value can be 0. So now the values that we need would be if 2x plus 4, which is the value inside the square root, is greater than or equal to 0. That means this value should be greater than 0, or this value can be 0 itself. So this is greater than or equal to 0. Now we can solve this inequality now to find the actual value of x. So we move 4 to the other side, and we have the 2x is greater than or equal to negative 4. We divide both sides by 2, and then we have that x now is greater than or equal to negative 2. So these are the set of values that if you insert into this equation is going to give you an actual value. So we can then say that the domain would be values. Now I'm going to use a square bracket. Now a square bracket means that the value that I want to write down there at this stage would be inclusive. Now if you look at this, you are saying x is a set of values that are greater than -2, and also equal to -2. So -2 is also included, and then from -2, remember we're saying greater than. So if you go through your number line, this is 0, and let's say at a point here would be -2, at a point here would be 2. Let's say it goes like that, 1000. At a point towards this thing is going towards infinity, there will be infinity at this point, and at this point we have a negative infinity. So if we are saying that the values are greater than 2, that means the values are from 2 here, and then it's going towards this direction, and this direction is going towards infinity. So the value would end up towards infinity. So we're going to use a moon bracket to show that infinity itself is not inclusive. Alright, but if you insert infinity into that equation, the whole of the equation becomes infinity. Alright, so that is the domain that we can get in these set of equations. Now, what are the range? Now that we said that the range are the outcome or the output, now we can then say that the range now that we're going to get from here would be, now let's start with the boundary, which is -2. If you have -2 in this equation, 2 times -2 plus 4 is going to give you 0. So the values will start from 0. And then if you increase the number now to -1, -1 here will be 2 times -1 is -2 plus 4, which is 2. You see the values are now gradually increasing. If you use 3, this will be 2 times 3, which is 6. 6 plus 4, which is 10. The value is increasing. So the value will be increasing from 0, where 0 is inclusive because of this equal to, and then it will also be going towards infinity because it's moving, it's increasing. So values that are increasing is moving towards infinity. Alright, and then you put your moon bracket. So these are the set of ranges that we can have from this set of equation. Alright, so let's check out the third one. So for the third, for our C, we have that h of x is equal to 2x plus 1 if x is greater than 0, and x squared if x is greater than and also equal to 0. Alright, so now we have this condition. Now there are two conditions here, that if x is greater than 0, just greater than 0, we have 2x plus 1. So you insert those values there to have the values. You insert the values, which is the domain, to have your ranges. And then if x is greater than and also equal to 0, we should use x squared. Alright, so this equation really now is majorly for 0, while this other one is for values that are greater than 0. Okay, so here we see the ranges. The ranges in the domain in these two cases has a correlation greater than 0, and then includes 0. So we can say that the domain now the domain of h of x would be, the domain of h of x would be a value that starts from 0, but 0 is not inclusive. Numbers that are greater than 0 and moves towards positive infinity if x is greater than 0, and also it will be a value that includes 0 moving towards infinity if x is greater than or equal to 0. So those are the ranges that we have. The domain that we have. The domain is between 0 and infinity. So we can say that the domain there is between 0 and infinity. Alright? And then for range, the range, which is the set of values that we can have, would be the set of value that we have in this particular case. Numbers that are greater than 0. If the value is greater than 0, then the value should also be greater than 0 in this case, and the number should be greater than 0. The number should be greater than 1 anyway. The number should be greater than 1 because whatever value you have here, when you add it to 1, the number will have to be from 1, but 1 not inclusive, because 1 can only have 1 if this place is 0. So the number will increase from 1, towards the positive infinity. Okay, if x is greater than 0, and the number here will start from 0 and increase towards infinity, where 0 is inclusive, because if you have 0 here, the answer that you have will also be 0 if x is greater than or equal to 0. So the range that we have here starts from 0 towards positive infinity. The range starts from 0 and move towards positive infinity, because 0 here is also inclusive there. Alright, so let's look at the fourth question. So the fourth question says that f of x is equal to 1 all over root of 2x plus 5. Now we should find the domain. We have to find the domain and also find the range. So for our domain, we have to consider two things here. One, we have to consider that we have an even root, and also consider that we have a fraction. So we have a numerator and we have a denominator, and when you have a fraction, then you should be careful with the denominator, because the denominator must not be equal to 0. The square root should not be negative, and then for fraction, denominator should not be equal to 0. Denominator should not be equal to 0. Then on the roots should not be negative. So those are the two things we need to consider when we are trying to find the domain and the range. So now the denominator contains a square root, and it's also the denominator. So let's look at it now. Based on the root, and we're saying it should not be equal to 0, then we can say that 2x should not be less than 0, based on the fact that 2x here should not be negative. Alright, this value should not be negative, and also 2x should not be equal to 0. So this value should not be less than 0, and this value should not be 0. So if it is not 0 and it is not less than 0, that means we are only considering the positive side. So what we are trying to say is that if this equation here, we have 0 here, and we have set of negative values, and we have set of positive values, it should not be all this. So all we are considering is this other part. So we can then say that 2x should be greater than 0 and not equal to 0. Greater than 0, not equal to 0. Alright? So greater than 0. Now from here we can divide both sides by 2 and have that x is greater than 0. So the values of x here should be greater than 0. That means all the values of x should be positive values. Okay. All the values should be positive value. Let's check it out now. So the domain will now be all numbers from 0, where 0 is not inclusive. So I'm using a moon bracket. If 0 was inclusive, I would have added a square bracket from 0 to your positive infinity, because it's pointing towards a positive. Okay, moving towards a positive, greater. All right. Then the range now would be, if we insert these values into this equation, what are the set of values that we're going to have? So what we have now, if we impute the values that we have here in the domain into this equation, what are the possible range that we're going to have? Now, from this equation here that we have, since it is an inverse, a denominator like this, numerator and a denominator, when the value on the denominator is very small, when we take the reciprocal of it, it's going to become very large. Okay, and it's going to be very large, moving towards infinity. All right, the smaller it is towards getting towards 0, it will become very large, getting towards infinity. All right, and then if the value is very large, getting towards infinity, 1 over a very large number becomes a very small number. Okay, and when you add that number to 5, it becomes 5 points, whatever value that they have, whatever, however that small the value is, 0.000000001. When you add it to 5, it becomes 5 plus 0.000. So the value here would start from 5, not exactly 5, because we cannot have 5 here, because there is no way this value will give us 0. So they can have 0 plus 5. There is no way this value can give us 5 exactly. So the value will not include 5, but will start from 5 and increase towards infinity. So that's the range that we can have from this equation. Now let's look at the last one. The g of x equals to the square root of 4 minus x squared over x minus 1. All right, now this is a case where we have a root again and a denominator. So take note of the rules there. The root should not have a negative value, and then the denominator should not be 0. So those are the two things you need to take note of. Based on the fact that the root should not be negative, then the root can be 0. Now the root can be 0 here because it's not at the denominator. The root can be 0 and can also be positive value. So that means that x minus x squared should be greater, since greater means positive value, greater than 0, and can also be equal to 0. So we add that, equal to 0. So we say 4 minus x squared is greater than or equal to 0. Okay? All right. And then what you also need to take note from the denominator is that x minus 1 should not be equal to 0, which then means that x, if you move 1 to the other side, should not be 1. Because if x is 1, then 1 minus 1 will make it to be 0. So x should not be 1 and x should not be equal to 0. Okay. All right, now let's look at the ranges of values that we have here that will give us a value that is greater than 0. So if you look at this is difference of 2 squared, 4 is 2 squared, and then we have x squared. So we can represent it as x minus 2 in one bracket, and 2 minus x in one bracket, and 2 plus x in the other bracket. Okay, and it's greater than or equal to 0. So how do we solve this inequality? Now, from what we have here, x can have two values. X can have a value of 2 and x can have a value of negative 2. So we can then go on to say that x is greater than or equal to 2, which also means we also have to test x is less than or equal to 2, then test x is greater than or equal to minus 2, and x is less than or equal to minus 2. So these are the set of values that we need to test here. So testing these values, let's look at this one. X is greater than or equal to 2. And if x is greater than or equal to 2, let's say x is 3. Let's say x is 3. And if x is 3 here, let's look at what we have here. 4 minus 3 squared. 3 squared would be 9. And then 3 squared would be 9. So 4 minus 9 is not a value greater than 0. It's a value less than 0. 4 minus 9, that's minus 5. So it's a negative value. So this is not the answer. So we go with this one. X is less than 2. X is less than 2. Let's use 1. So we say 4 minus 1 squared. 1 squared is 1. So 4 minus 1 becomes 3. And 3 is a value that is greater than 0. So this is one of the solutions to this equation. Then let's check x is greater than minus 2. X is greater than minus 2. So the value that is greater than minus 2 would be minus 1, the one that is closer to minus 2. So minus 1. So let's test minus 1. 4 minus 1 squared. Minus 1 squared is 1. So 4 minus 1 remains 3. So that value 3 is greater than 0. So this is also an answer to this equation. So this other one is not a solution. So these are the two solutions that we have for this equation. So let's consider those two solutions. So what we have gotten here is that x should be greater than or equal to minus 2, and x should be less than or equal to 2. So based on what we have here, we have ranges of values that start from, let's write our number line. This is 0. Let's say at this point we have minus 2. Let's say at this point we have 2. Because this is the negative part, this is the positive part. So the ranges of values start from negative 2 here. And from negative 2 is moving towards this side. And then from 2 is decreasing because 2 is saying x is less than 2. Less than 2 is going towards this direction now. Okay? So we know that these values is going to meet at a point. So these values range from this point. But still in this point, we say that x should not be equal to 1. So there's a point here, 1, where the value of x cannot be. You cannot have a value of x at this point. But we have a value of x closer to the point, have a value of x closer to this point from the right and from the left, but we do not have a value exactly at 1, because if you have 1 here, 1 minus 1 will become 0, and we don't want the denominator to be 0. All right, so now let's try to now form the range and the domain. All right, so let's start with the domain. For domain, the set of values will be x is minus 2. So from minus 2, moving upward, but there is a disconnection at this point. So x is greater than minus 2 and moving towards 1, but not 1. So we use a moon bracket. Union, which means combine that with from this other point, not equal to 1, moon bracket 1 again, moving towards this side to 2. It ends at 2, and the value here 2 is inclusive because x is also equal to 2. X is also equal to 2. X is also equal to minus 2. That's why we use the square bracket here, the moon bracket, which means that 1 is not inclusive, and the square bracket. So if we combine these two together, which means that this part is for this other side and this other one is for this other side, combine together, it means everything here without 1. Okay. All right. So those are that's the domain. Now let's talk about the range. What then would be the range? What would be the set of answers, solutions that we'll have if we we put in these values here? Now, to find the range of this equation, you look at it now from this minus 2 here, we know that if you insert minus 2 in this equation, that you're going to have 0. Okay? But as you're moving towards 1, as you're moving towards 1 from minus 2 here, the values that you have would be negative. For instance, from minus 2, as you're moving towards 1, if you insert the value 0, you insert the value 0 here, find out that the value that you have will be negative. So that means that the values at this point are all negative. Value at this other point from minus 2 towards 0 to 1 are negative. But as it's getting closer to 1, your value is getting closer to infinity, because if you put 1 here, 1 minus 1 becomes 0. Okay, so it's moving towards infinity. All right. Now, if you also look at these two here, insert 2 into this equation. 2 here will make it 4. 4 minus 4 is 0. So the equation like that boundary is 0. But as you're moving closer to 1, the values are positive. But as it's getting towards 1, the values are getting close to infinity. All right. So we can then say that the values that we are going to have are going to be from your negative infinity towards your positive infinity, but not inclusive. None of these values are inclusive. So we're going to use a moon bracket, for your negative infinity to your positive infinity. And that would be the range of that equation. All right, so thank you very much. I hope these have been useful and beneficial to you. Please subscribe if you've not done so, and thank you.